This is Saturn. It's easy to get lost in the magnificence of this gas giant crowned with its gleaming rings. There's just something inexplicably beautiful and mesmerizing about this planet, which makes it one of the most photographed and studied in our solar system. And yet, despite all we know about it, there's still so much that we don't. What mysteries does the ringed king hold, and how did it come to have such a magnificent crown? Join me as we take a deep dive into everything Saturn. Let's start by taking a look at the stats on this gas giant. Saturn is the second largest planet in the solar system, coming in at a spry 95 times the mass of our good old Earth. Now I say spry, but if you want to get a sense of just how huge Saturn is, then consider that if our sun were the size of a basketball, Saturn would be the size of a grizzly bear. To put that into perspective, Earth would be the size of a sesame seed. Saturn is also pretty far out in the solar system. It sits at an average distance of 9.5 times the Earth-Sun distance. This means that sunlight takes about an hour and 20 minutes to reach Saturn, resulting in the planet only ever experiencing twilight conditions. Because of this, the planet is often shrouded in darkness, making it hard to observe and adding to its mystique. Like Jupiter, Neptune, and Uranus, Saturn is a gas giant. This means it doesn't have a solid surface and is largely made up of hydrogen and helium. There is some evidence that at the core of the planet there may be a rocky or metallic center. But given the extreme pressures and temperatures found deep within the planet, studying its composition is very difficult. Saturn is named after the Roman god of agriculture and wealth. And like many of the planets in our solar system, it was known to the Babylonians as early as 800 BC. It's the only planet in the solar system that has rings visible to the naked eye. These rings are made up of countless fragments ranging in size from tiny specks of dust to massive ice blocks larger than houses. We think there are over 150 rings surrounding the planet, but exactly how many is still unknown. Each ring is opaque, spanning hundreds of miles across, but only a few miles thick. All of the rings combined are over 10,000 miles wide, which is almost the length of the United States. But enough about the basics. Let's talk about what makes Saturn so fascinating, its rings. First seen by Galileo Galilei in 1610, Saturn's rings have captivated astronomers and the general public alike. They are so grand, so intricate, and so bafflingly beautiful. Scientists believe the rings are mostly made up of water ice, although the exact composition is still being investigated. Given their thinness, their transparency, and the fact that they don't obscure stars behind them, it's believed that there are gaps between the various chunks of ice. The reason why the rings don't melt despite being so close to the sun is because they're so far away from the sun in the first place. And because the majority of the rings are made of ice, it's believed that the temperature remains low enough to keep them frozen solid. Now, the rings themselves aren't actually attached to Saturn. Instead, they're thought to be a collection of independent bodies held in place by Saturn's gravity. They range in color from pure white to gray to black. And the differences in color are due to variations in ice purity and the presence of other materials, such as rock and dust. Of course, these days we've got some incredible shots of Saturn's rings taken by NASA's Cassini probe. What's amazing about these rings is that despite looking so static in photographs, they're constantly moving. Chunks of ice are always crashing into each other, creating new fractures and reshaping the rings over time. Despite their apparent simplicity, Saturn's rings are actually a complex and dynamic system. Astronomers classify them based on various properties, including their shape, structure, and chemical composition. The rings are divided into smaller divisions, each with unique characteristics. For example, the Cassini division, named after the Italian astronomer who discovered it, is one of the largest gaps in the rings. Within these divisions are smaller ringlets and spokes, which are intermediate in complexity, offering insights into the dynamic processes occurring within the rings. Scientists continue to study these rings to unravel their mysteries, using observations from missions like Cassini to piece together their formation and evolution. If you think that's enough to blow your mind, wait until you hear about Saturn's moons. Like many of the planets in the solar system, Saturn has several moons that add another layer of complexity and wonder to this already intriguing planet. As of today, we've managed to identify at least 146 moons orbiting Saturn. That's more than any other planet in our solar system except Jupiter. Most of Saturn's moons are small, ranging in diameter from a few miles to several hundred miles. But some of them, like Titan, are quite large. Titan, the largest of Saturn's moons, is particularly intriguing. Not only is it the second largest moon in the solar system, but it's also the only moon known to have a dense atmosphere. It's so dense, in fact, that it even has its own weather system. Here on Earth, water exists in liquid form, but on Titan, the primary constituent of its atmosphere is methane, which exists in liquid form. So while it may seem strange to imagine rain falling from the sky on Titan, it's not entirely out of the question. Titan also has lakes and rivers made of hydrocarbons, which are organic compounds consisting of hydrogen and carbon atoms. These lakes are located in the moon's equatorial region, where temperatures are high enough to keep the hydrocarbons in liquid form. The largest lake is known as Kraken Mare and is so big that it can be seen from Earth with a good telescope. But Titan isn't the only moon that has captured our interest. Another moon, Enceladus, has more than 100 known water jets that erupt from its surface, giving us a glimpse into the potential for life beyond Earth. These eruptions, which can reach heights of over 300 feet, are caused by the release of water vapor from the moon's interior. The vapor is created when Saturn's gravitational pull heats the ice below the surface of the moon. When it reaches the surface, the vapor erupts out of the cracks in the ice, creating a spray that can be seen from Earth. Beneath its frozen exterior, scientists believe that Enceladus could harbor a vast ocean of liquid water. This discovery was made by the Cassini spacecraft, which detected the presence of water vapor in the plumes of ice grains erupting from the moon's south pole. The discovery raised hopes that the moon could have the necessary conditions for life to exist. And since then, scientists have been eager to learn more about Enceladus and its potential for hosting extraterrestrial life. The future holds exciting possibilities for exploring Saturn and its moons. Upcoming missions such as NASA's Dragonfly spacecraft will continue to unravel the secrets of this fascinating planet and its moons, providing us with even more breathtaking discoveries. Our exploration of Saturn took a monumental leap forward in 1997 with the arrival of the Cassini spacecraft. After a 7-year journey, Cassini entered orbit around Saturn, marking the beginning of an extraordinary 13-year mission that revolutionized our understanding of the ringed planet and its intricate systems. During its time in orbit, Cassini made countless groundbreaking discoveries. It revealed the intricate details of Saturn's rings, providing a close-up view of their stunning complexity and dynamic nature. The spacecraft also explored Saturn's diverse moons, uncovering their unique characteristics and potential for hosting life. One of the most significant contributions of the Cassini mission was the discovery of water plumes erupting from Enceladus. These plumes provided evidence of a vast underground ocean on the moon, raising the possibility of extraterrestrial life. Additionally, Cassini's investigation into Titan revealed the moon's dense atmosphere and organic lakes, showcasing the unique environment it offered for scientific study. The spacecraft's instruments analyzed the composition of Saturn's atmosphere, providing valuable data about its weather patterns and climate. Cassini's legacy extends beyond its scientific discoveries. Its final dramatic dive into Saturn's atmosphere in 2017, ensuring that it wouldn't contaminate the planet with its descent, left an indelible mark on the world of space exploration. Despite their ethereal beauty, Saturn's rings are not eternal. They are slowly but surely disappearing, raining particles onto the planet's atmosphere and eventually disappearing altogether. Although it may seem like a tragedy, it's simply part of the natural cycle of our universe. Saturn's rings are not just a marvel to behold, but also a testament to the dynamic and ever-changing nature of our cosmos. Their eventual disappearance will not be an ending, but a transformation, leaving behind a legacy of wonder and inspiring continued exploration of the mysteries that lie beyond our own planet. Saturn is not just a distant planet, but a gateway to understanding the vast complexities and wonders of our universe. By exploring its magnificent rings, diverse moons, and dynamic atmosphere, we gain insights into the very origins of our solar system and the potential for life beyond Earth. As we continue to unravel the secrets of Saturn, we are reminded of the boundless curiosity and spirit of discovery that drives humanity is exploration of the cosmos. And who knows, maybe one day we'll witness the birth of new rings, or discover new moons, and even life itself on this majestic planet. Until then, Saturn will continue to reign as the crowned king of the solar system, captivating our imaginations and inspiring our dreams of exploration and discovery.